Hello everyone, welcome to another video from Advanced Math Tutors. Today, on our series of alternative math, I wanted to present to you with a solution to a word problem. And this word problem was actually asked to me in a technical job interview, so you might want to remember the solution. And as always, there are two solutions. One is a little bit more complicated than the other, but I will present to you with both, all right? So the problem is, a species of bacteria doubles in population each day. After 50 days, the bacteria occupy one whole petri dish. How many days does it take for the bacteria to occupy half the petri dish? All right. And so what we can do is we can pull out our growth formula. And so that would be P, so that's our current population, is equal to rho naught times 2 to the t power, where t is the number of days, right? So if the population doubles every day, after 50 days, we would just be taking the original population and multiplying it by 2 50 times. But multiplying something by 2 50 times is the same as taking 2 to the 50th power. All right? And so we're actually given a point here. We know that when t is equal to 50, when t equals 50, our p is equal to 1 whole petri dish. All right, so we can put that in. We know that 1 is equal to rho naught times 2 to the 50th power. All right, and now we can solve for rho naught with this. We can say that rho naught is equal to 1 over 2 to the 50th. I'm going to write it like this. 2 to the negative 50. All right? And that's just to make computation a little easier in the future. And so let's go back to our formula, plugging in rho naught. So we want to know when p is equal to a half, here's the question. What is t? We're looking for what t is when the population is equal to half the petri dish. All right? So let's start this out. Let's just set p equal to a half. Let's say 1/2 is equal to rho naught here. We just solved for is 2 to the negative 50. And now we're multiplying that by 2. And we want to know how many days it takes. So we're solving for t. All right? And I'm going to write 1/2 as 2 to the negative 1. And this will be clear in a second. And now we can combine. So when you have, let's say you have 2 to the negative 50 times 2 to the t. When you have monomials with the same base, you add exponents. So this is equal to just the sum of the exponents, or 2 to the sum of the exponents, which is negative 50 plus t. All right, and so let's substitute that in. We can substitute the entire right-hand side just for that quantity there. We have 2 to the negative 50 plus t. All right. And now we can take the log base 2 of both sides, and that will just give us the the exponents. So we get negative 1 is equal to negative 50 plus t. And so if we move 50 to the other side, we can see that we'll get 49 is equal to t. And that means after 49 days, the population of bacteria will occupy half the Petri dish. All right? And so that's one way to do it. There's also another way to do it if you just think about the problem intuitively. So we know that the species of bacteria doubles in size each day, and after 50 days, the bacteria occupies a whole petri dish. That means uh, when the uh, when the bacteria occupies half the petri dish, it must be the day before it occupies the whole petri dish because in that one day it doubled from half to a whole. And that means it must be the day before 50 days. So we get 40, it must be 49. And so our answer down here, when we went through all the math, makes sense. All right. And that's kind of the trick. You can actually solve this problem in seconds without doing any complex computation. Um, and so that's kind of the point of the question, is to stump you like that. But you can go through the computation, and as you see, you get the correct answer both ways. So I hope you enjoyed it. Make sure to like and subscribe, and have a great day.